So here in our last example, the base is a region enclosed by y equals sine x from 0 to pi. And each cross-section is an isosceles right triangle whose hypotenuse is lying perpendicular to the x-axis. So that means in this picture, here's sine x, and our cross-section perpendicular to the x-axis is the hypotenuse of an isosceles right triangle. So if we think about this right triangle, we pull it out. An isosceles right triangle is really just a 45, 45, 90 triangle. The length of this hypotenuse is sine x. So if we're looking for our leg, that's equal to our hypotenuse divided by the square root of 2. In this instance, our hypotenuse is sine x divided by the square root of 2. Now that we know our two legs, the area of this isosceles right triangle is 1/2 multiplied by the leg squared, because our leg is both the base and height. So now we can set up an integral to find this volume. The integral will put infinitely many of these isosceles right triangle from 0 to pi. And the area of each of those triangles is 1/2 multiplied by my leg squared, multiplied by the thickness of this cross section, which is a very small change in x. So remember, our leg is sine x over square root 2. So now that we've set up this integral, let's go ahead and solve it. So if I square this, I have volume equals 1/2 integral of sine squared x over 2 dx from 0 to pi. I'm going to go ahead and pull out this over 2 to my denominator out here. So that's 1/4, excuse me. The integral from 0 to pi of sine squared x dx. Now this is a special integral because we're actually going to need to apply one of our trig identities that hasn't really come up yet so far this year. Sine squared theta is the same as 1/2 times 1 minus cosine 2x dx, or sine squared x, not sine squared theta. So this is a trig identity that we need to know. There's also one for cosine squared. Cosine squared is 1/2 times 1 plus cosine 2x. So this will come in handy whenever you're integrating sine squared or cosine squared. So now that I've applied this trig identity, I'm going to pull out this 1/2 in front. So now I have volume equals 1/8 integral of 1 minus cosine 2x dx from 0 to pi. So we do know the antiderivative of 1, but we don't know the antiderivative of 2x. So I am going to let u equal 2x, because if we let u equal 2x, then we'll have cosine of u, and we do know that antiderivative. So that makes du equal to 2 dx, or 1/2 du equals dx. So this 1/2 is going to end up coming out in front. Now I don't want to forget changing my limits of integration to be in terms of u as well. U of 0 is 2 times 0, 0. U of pi is 2 times pi, 2 pi. So now this problem changes to, so 1/2 times 1/8 is 1/16 integral from u equals 0 to 2 pi of 1 minus cosine u du. So now I can find this antiderivative. This is 1/16 u minus sine u from u equals 0 to 2 pi. So now I can plug in my limits of integration. My volume equals 1/16 of 2 pi minus sine of 2 pi, subtracting 0. Because if I plug in 0 into either of these, it cancels out. So I know that sine of 2 pi is 0. So my final answer is 1/16 times 2 pi. So that's 2 pi over 16, or pi over 8 units cubed. So this problem was great because not only does it review an isosceles right triangle relationship, but also uses this special trig identity that doesn't come up too often, but is fair game.